Austin is standing on a high dive at the local pool. So let's draw. So I'm thinking of a swimming pool. And swimming pool has water. Austin is standing on a high dive. So here's the high dive. Sounds kind of weird. You need a point of reference, so do draw Austin. Two of his friends are in the water on the opposite side of the pool. So the opposite side would be something over here. There's two friends. Two of his friends are in the water on the opposite side of the pool. If the angle of depression, so remember, Austin's peering out into life, pondering life. What is the meaning of life? Who created this math? And then one of his friends says, "Hey, I love math." And Austin's like, "Huh?" And then Austin looks down. And then maybe they're doing the project video, right? Would be cool, right? They're underwater, they have their cameras, they can record, and one of you guys jumps into the pool. That'd be cool. No one's done that in my projects yet.
Okay.
Okay, so the first person question. Remember, the angle of depression is from the line of sight to that angle there. In pink, do you think that's going to be a big angle or a small angle? Yeah, that is a bigger angle than the other one, which will be just to that first line. So that would be the 40 degrees. And then the smaller angle, or the smaller triangle, is here in yellow. That would be my 30 degrees. So, if the angle of depression to one of his friends, I love math, that's 40 degrees. I love math too. Down is 30 degrees, that's the second friend. To his friend who is 5 feet beyond the first friend. So that means the distance is 5. Let's mark that in color. The 5 feet is right there. How tall is the platform? So I'm going to call this one X. And then because in a triangle, okay, a common mistake for students is your small triangle is here. It's a right triangle. And then your second triangle is not 5. This is called a scalene triangle. None of the sides are congruent. You see that? It's not even a right triangle. So I need this other variable here. I'm going to call that one Y. There I did my first strategy of just getting one triangle. Let's get 2 triangles. 2 triangles. Let's draw 2 more triangles. Nathan's thinking in his head if he wants to do the small or the big triangle as I'm drawing these. Nathan, which triangle would you want to do? You want to do the big one. Okay. Oh, I drew my triangles. So I drew mine. The slant's going this way, right? But the angle of depression has it this way. So you could have drawn your triangles this way and still solve it. So if you want to do the other way, let's use our class, that dotted part of the angle is going to be how many degrees? If this is 40, can this be 40? No, that's the common mistake, right? Just to write 40 down there. Remember, depression means going down, so you have to go from line of sight going down. So if this is 40, Nathan, this one will be, thank you, Nathan, 50. And then, Nathan, how much would be the other angle?
60.
Yeah. 60. So, if you can't see it, alright Nathan, tell me the big triangle. Wait. So look at. This is my big triangle. Let me pick a color. This is the biggest triangle, right? Blue, 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 blue. Blue, blue. You said 60? 40, 30, or 50?
40.
Remember, 40 degrees would be here.
Oh, it would be 50, right?
Does that make sense? So you're doing from here. That yellow should go all the way down to there. No. Look where my blue is. Do you see where the blue is? So your choices are 50 or 60. 60 is correct. Do you guys see that? It's 30, and then this one is 60 degrees. From this blue triangle, from here to here, is 60 degrees. Okay, Nathan, keep going.
The opposite side would be x, right?
The opposite side would be x. Angle depression to one of. Yeah, that's right. Say again.
The opposite would be x.
This side?
No,
This side.
yeah.
And how about this one down here?
It'd be y plus 5.
Y plus 5. Now, for those of you who looked at the picture that I gave you guys, right? I gave you guys time to copy the problem. You had time to draw a picture, and then I showed you the answer from the textbook or the problem I gave you. They actually had 30. You guys remember seeing that? It's because it's a what? 30, 60, 90. That's 180 degrees. Okay? Alright. How about Kayla? Help us draw the smaller triangle. Let's make this in green. Ready, Kayla? Do you want to do the angle on the left here or on the right? Okay. So what angle goes there? 50 is correct. So angle of depression is 40 to the green, and then the dotted is the 50 that we just drew. Keep going.
The side is the x, and then below that is the y.
Yeah, just the y. Alright, I'm going to let you go. You guys are going to solve for y. You're going to substitute them or equal to each other. So you have, as Jocelyn had said earlier, you're going to create a proportions. And then you can solve the problem. So let's solve for a variable. Again, if I notice these problems, it's best to just solve for x because they already both have an x. But because I already told you to solve for y, I'm going to do that. It's a little bit longer, but we'll get an answer. Starting point is here. I have the opposite, and from here I have the adjacent. So I have, for this big triangle, tangent of 60 equals y plus 5 over x. Now, if you wanted to solve for y, it's a little bit more work. Might help us in the future. I'm going to get x times tangent of 60 equals y plus 5. And then if I want to solve for y, I'm just going to subtract 5. So I have x times tangent of 60 degrees. Those are by multiplication, and then subtracting 5, that equals y. Raise your hand if you got that. Uh-oh. Alright, in this triangle, if I wanted to solve for y, it doesn't make sense to solve for y, 'cause you'll see at the end. For this triangle, I'm going to do the same thing, opposite, tangent of 50 equals y over x. And then I want to solve for y, so I'm just going to cross multiply. I get x times tangent of 50 equals y. Now again, yours might look slightly different if you chose to use the 30 and 40. But based on what I've told you so far, that's what we got. Alright. Let's do the substitution. So if I set these equal to each other, I get x tangent of 60 minus 5 equals x tangent of 50. My goal here is to solve for x. So let's go ahead and do that. Remember now, this is by subtraction. This expression minus this expression. So to get my x's together, so that I can take out the greatest common factor, I'm just going to subtract this whole thing over. This is positive, and then the opposite is a negative. This is going to get me negative 5 equals x tangent 50 degrees minus x tangent of 60 degrees. Pull out my x. So x times tangent of 50 minus tangent of 60 equals negative 5. And then if I divide both sides by tangent of 50 minus tangent of 60, I'm left with the calculator ready equation. X equals negative 5 divided by tangent of 50 minus tangent of 60. Let's punch it in. Remember, for the TIs, your negative sign is different than your subtraction sign. Use extra set of parentheses. Tangent of 50 minus tangent of 60. Da-da-da-da! You want to see my calculator buttons or the screen? Is that okay? And if you round to the nearest tenth, you get 9.3. 9.3. Raise your hand if you got that. You guys got it? Yes! Austin is diving off. I don't know if you guys realize, 9.3, is that meters or feet?
Feet.
Oh, feet. Okay. Not too bad. Jumping off the basketball hoop. Take your time.